Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nur Aini Ahmad. Saya dari kumpulan 1. Saya akan membentangkan tentang earthwork layout plan. Okey, saya ada wakil daripada grup saya untuk infrastructure. Okey, yang pertama saya akan membentangkan tentang earthwork boundary layout. Untuk earthwork boundary layout dia ada 3 elemen yang penting. Yang pertama adalah apartment, yang kedua adalah cut and fill area, yang ketiga adalah boundary. Okey, saya telah mempropose 2 garisan cross section. Yang pertama cross section A to A, cross section B, yang kedua adalah cross section B to B. Okey, ini adalah hasil daripada calculation cut and fill untuk section A to A dan section B to B. Okey, yang cut and fill daripada daripada kiraan dia lah. Lepas tu yang kedua saya akan propose layout plan untuk earthwork construction layout. Okey, untuk earthwork construction layout dia ada beberapa elemen yang telah dipropose. Yang pertama sekali yang paling penting adalah kami telah mempropose boundary sendiri kerana tiada boundary existing boundary yang berdekatan dengan kawasan kami. Lepas tu yang kedua adalah kami telah mempropose slope sendiri. Okey, slope kami sendiri bernisbah 1/2. Okey. Lepas tu yang penting juga adalah temporary road. Yang temporary road dihasilkan berdasarkan daripada permanent road yang akan didesign selepas earthwork kerja earthwork. Lepas tu kerja tanah. Lepas tu yang ketiga adalah yang penting adalah earth drain. Saya telah mempropose earth drain dalam layout saya, stockpile area, machinery and material storage. Lepas tu untuk yang ketiga, untuk layout yang ketiga, saya akan menceritakan tentang section A to A. Okey, untuk section A to A tadi, cut area dia adalah lebih besar daripada fill area. Jadi kita tahu kawasan ni adalah kawasan apa? Kawasan yang rendah, kawasan yang tinggi. Jadi untuk kawasan yang tinggi, cutting area dia nilai cutting area dia adalah 2355.8 meter square. Lepas tu untuk fill area adalah 1243.03. So dia 2 kali ganda. So dia akan mendapatkan nilai yang berlebihan daripada cut and fill untuk A to A ni lah. Okey, untuk section B to B juga dia lebih kurang saja dengan A to A. Dia hanya kurang sedikit untuk cut, tapi fill dia lebih kurang saja. Jadi dua-dua section tadi dia adalah menceritakan tentang kawasan yang tinggi. Dia menghasilkan kawasan yang tinggi. Jadi kawasan ada berlebihan tanah mungkin akan dibuat sebagai stockpile masa hadapan. Terima kasih, itu saja daripada saya.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Dan selamat petang kepada Dr. Halim. Nama saya Muhammad Badrumi bin Masri. Saya akan menerangkan berkenaan dengan road design system. Okey, pertama sekali, lokasi pembangunan dan pembinaan yang dicadangkan terletak di USD 25, Subang Jaya, Mukit Damansara, daerah Petaling, Selangor Darul Ihsan. Okey, cadangan pembinaan jalan bagi kerja-kerja infra adalah seperti gambar yang dapat kita lihat sekarang. Kawasan jalan bagi projek kami adalah R1, iaitu piawaian kawasan geometri yang rendah dengan kelajuan bagi kenderaan adalah tidak melebihi 40 km per jam. Okey, mengikut rujukan daripada arahan teknik jalan 8/86, untuk jenis jalan R1 ia dikenali sebagai single lane minor road dengan kerata rentas. Kalau kita boleh lihat ni, kerata rentas untuk 50 mm untuk wearing cost, 50 mm untuk binder cost, 30 mm untuk crash run base cost dan 50 mm untuk sand. Okey, untuk cadangan pembinaan jalan kami mencadangkan 3 papan tanda, iaitu papan tanda tempat meletak kenderaan, papan tanda berhenti dan papan tanda jalan sehala. Okey, kami telah mencadangkan penggunaan tanda jalan atau road marking mengikut spesifikasi JKR yang telah ditetapkan. Okey, ini adalah detail untuk road curb bagi pembangunan dan cadangan bagi pasapuri yang kami lakukan. Sekian, terima kasih.
Assalamualaikum, my name is Nur Afifaizati. I will explain about design of drainage for infrastructure. Basically, drainage is a method on removing surface or subsurface water from a given area. For residential area, drainage helps in wastewater away from walkways, driveways, and roof to avoid flooding. As for good drainage system, there are several requirements that need to be satisfied, which is surface water should not percolate to track, and should be effective such drains and proper outfall. So this is our drainage layout for full plan layout. The drainage is in purple color, and for the invert level, we use formula which is road level minus depth of drains, and for others invert level which is not have road level, we use the Pythagoras theorem with gradient to get the invert level. And as for the sum invert level, we use the formula which is with road level minus depth of drains and minus 0.15 depth of sum. Then this is the catchment area for the drainage system, which is in the blue line color. Okay, the catchment area is get from the highest road level to the drain, and for others is use from the earth drain or existing drain to the drain, and it also can be used as a boundary to the drain. So this is the longest length, which is L0 for the catchment area, which is the LO get from the catchment line of catchment area to the drain, and the area for the catchment area have been calculated. Okay, this is the detailing for drainage system, which is this is the cross section for some from the box culvert, which is the box culvert is 900 times 900 millimeter size, and the detailing shows the direction of inlet drain and outlet drain with the thickness of cement render. Okay, this is the cross section for entrance culvert, the dimension, and the drain section for the drainage, which is we use 300 millimeter half round drain with base concrete 150 millimeter width. Okay, this is the calculation for drainage design. We use Microsoft Excel for calculate the data, and as for this, we insert the data that we get that we refer to the Urban Stormwater Management Manual for Malaysia, or call it as MASMA, to obtain the data coefficient for selected area or selected state, which as for our project we do the project on Selangor. So the data from Selangor we get it from MASMA, and we insert in the spreadsheet, and we calculate, and we get the drainage discharge water we get from the rational formula, which is Q equal to CIA for calculate the water discharge, and we use Manning equation for calculate the water flow rate, and as a result for the calculation, we can determine the result on the drainage design is it pass or fail, and after we calculate all the section of drainage, we get all the drain section is pass. So our drainage design is acceptable. Thank you.
Untuk 4.0 sewage system are sewer network that we collect all wastewater from building to the sewage treatment plant. Okay, the wastewater will be collected via pipe, conduit and acid work that it will be treated at the treatment plant before discharged back into the environment. Okay, sewage system design, construction, installation, commission must follow the rule expect from Jabatan Perkhidmatan Pembentangan as known as the JPP and relevant authorities. So mostly Malaysia menggunakan JPP iaitu Jabatan Perkhidmatan Pembentangan untuk sewage system. Okay, 4.1 adalah manhole. Okay, sewage system dia punya design kita dalam sewage system layout adalah manhole. Contoh ni JPP yang digunakan di Malaysia. Okay. Untuk design consideration for sewage system, kita ada 3 aspek kita kena consider, which is road layout, and benda ni adalah benda pertama yang kita kena pilih untuk buat layout sewerage. Road layout tu mesti ada. Kedua, kita kena cari existing manhole untuk ditarikkan kepada bangunan kita. Dan ketiga adalah development area. Kita kena tahu area yang kita design tu adalah rumah ke, atau shopping complex ke, atau tempat-tempat lain, sebab dia ada mempunyai PE tersendiri. Okay, untuk calculation, untuk projek kali ni, untuk PE, kami guna iaitu 38 unit apartment. So kita akan guna sebanyak 190 dan 38 unit. Okay. So untuk calculation manholes, kita propose untuk 4 manhole, and ada dan mostly design yang dikira melalui Excel adalah semua dalam keadaan status okey dan diluluskan. Tiada masalah. Okay, ini adalah contoh drawing projek kami untuk sewage system. Okay, kita propose manhole 1 yang berdekatan dengan apartment 5, iaitu apartment kita projek kami 38 unit. Okay, kita nampak warna kuning itu adalah road. Okay, road adalah penting dalam untuk sistem sewage layout. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhatin Hassan binti Hadi. I'm going to present to you for the part of the water supply. For a big introduction, for water supply system delivers water from sources to customers and provides service vital to function of industrialized society. Second one is, it is important to emergency response and recovery after disaster events such as earthquake. The third one is water supply system. WSS are networks whose edges and nodes are pressure pipes and either pipe joined to water sources or end users respectively. The diagram here is the typical water distribution, which is from the rain, and it will fall to the catch water, and then it will distribute it to the water treatment works, to the pumping station, to the primary service reservoir pumping station, and then distributed to the customers. Okay, this is the water supply layout. This one is the existing pipe from the node 1, and then it will flow to the node 2 here, the second node, and then this one is the third node. This one is our proposed building. So this is the area where the water supply system is installed. Okay, this is the close up for the water supply from node 1 here to node 2, and then we have suction pump, and then the water flow to the core valve, and then this is the bulk meter. The water flow to the parking area, distributed to the parking area. And this one is node 3. This one is fire hydrant and suction pump to distribute the water to the area of the building. Okay, next one is, this is the water supply part, which is called valve, the bulk meter, the node, the pilot hydrant, air valve, flow and sluice valve. Okay, second one is water supply calculation procedure. The first one is to determine the type of water demand and the daily water consumption. The second one is we have to calculate the average of flow of water. And the third one is we have to estimate the housing flow requirement to the total demand by using the formula of total demand Q, which is water demand in commercial building, and fire flow requirement. And then the next one is determine the flow rate and the velocity of water supply. Identify the head loss of pipe by using Reynolds number RE. Perform the calculation of pipeline from node to node by calculating peak flow rate, hydrant flow rate and fire flow rate. Calculate the residual pressure head at each node. So this is the requirement to calculate the water supply system. So the next one is water supply calculation. From here we refer the table from the Puas Berhad for the average water demand. So the building type is apartment. The water demand gallon per day is 350. So from the point apartment node 2, the unit is 38 and the total consumption is 350. So we multiply by the unit, we get the total consumption gallon per day is 13,300, and it goes the same for the apartment at node 3. So we total up the total consumption for gallon per day. So the total is 26,600. So the next one is we estimate the housing units and fire flow requirement, which is we refer from the Malaysia Water Association requirement. So we need to calculate the total demand, water demand in commercial building and fire flow requirement. So the building type is class A. So it have the 4,100 liter per minute. And the total demand is, we get is 0.069 meter cube per second. And the next one is we need to calculate flow rate and velocity of water supply. The proposed diameter of the pipe is 300 meters. So we need to find the area, which is pi r square. We get 0.071 meter square. And then the velocity we get is 0.97, which is less than 1.2, which is okay. So the table is the peak flow and average flow of water demand. We get for the apartment 2 is 0.33. The node 3 is 0.33 also. So the total is 0.66. Next one is we need to calculate the head loss of pipe. We use the coefficient of surface resistance by Reynolds number RE equals to 4Q divided by 5VD. So we get 3019 or 2.16 Reynolds number. And then we calculate for the pipeline, the calculation of total head loss in pipe. We get from pipe 1 between node 1 to node 2, we get head loss is 0.0035 meter. And then for pipe 2 between node 2 and node 3, we get 0.00020, and then the total of head loss is 0.0035, so which is less than 2 meter. So it is okay. The next one is the formula to calculate the head loss. We use Darcy-Weisbach friction factor. And the next one is we need to calculate the peak flow rate, which is equal to average flow multiplied by peak factor. So we get 0.55 meter cube per second. Next one is hydrant flow. We get 0.069 based on the Malaysian Water Association. And then the fire flow rate, we get 0.069 liter per minute. And then we calculate the residual head
which is we need to find the pressure from pipe 1 add by and then we to added the elevation of water source to node minor loss subtract to total head loss, so we get static head loss 0.000128 meter cube per second, and then from the pressure from pipe 1 we get 0.068 meter cube per second, so the residual pressure total is 26.8, which is more than 12 meters, so the pipe is so the requirement of the pipe is okay and follow for the requirement. So the design for storage tank we propose was to demand 5,961.6 meter cube per day. So we have two tanks, we divided by 2, so we get 2,981 meter cube per day. So the tank dimension we propose is the width is 35 meter, the length is 60, and the height is 2 meters. So each tank is 402,000.